Good. So let's proceed. We've talked about the objectives and the overview. So to get started, values. Let's talk about values and data types. What are values? Values are just one of the basic things that a program works with, right? You can talk about 25. 25 will be a value. Those who work in data fields, let's say data analytics, data science, databases, and so on, you understand a value could have many different types, right? So think about an Excel file maybe. When you enter records in an Excel file, you can enter a number or you can enter a character. Think about your trip also to the DMV. When they ask you to enter your information, you have to enter information of a particular type. If they ask for your age, you have to enter a number. You cannot say your age is eggs or your age is potatoes. Your age has to be a particular number. If they ask for your name has to be a series of characters, what is known as a string. So whatever value that you enter in there belongs to a particular type, be it an integer, and so on and so forth. So you would see that different data types usually can be grouped into two, either primitive or collections. Collections are more or less like sequentials, groups of stuff, right? You can have apples, a bunch of apples become a collection of apples, or you can have apples, bananas, oranges, then that becomes a collection of fruits. Or you can have oranges, eggs, plantains, bread, then it becomes a collection of food items, right? So collections are more complex data types, but the primitive, native, black and white data types, as you can see here, are integers. Integers could be more complex to be float. Float is a short way of saying floating point number. Floating point number meaning that decimal point can be in any location. It floats between numbers, whether it's one decimal place, two decimal places, and so on and so forth. So integer is a whole number. A float could be having more precision. Boolean is also another type which has to do with true or false, yes or no. It was discovered by, I think it's a certain French mathematician whose name is Boole, and they gave the name Boolean. Also, you have string. String is the one that's used for characters. You can have one character, you can have a set of characters. Think of hanging your clothes on a drying line, that those clothes make up a string. So you can say this is A, B, C, and D. It makes up a string of characters, which is a text or a word. All right. So all of those, again, the reason we do that is because we want to be able to specify what type of data so that we can know what operations we can do on them, which we'll talk about later on. And in Python, just like we started using the print function, you can use the type function to tell you the type of data that you have, okay? So let's go in and try real quick. In here, let's escape from that. If I go into my Jupyter notebook, let's open a new one and type 120, that's a value. It doesn't mean anything at this point in time because I have not assigned it anywhere. I can press enter. Python just returns me that particular value. I don't think you guys can see. Let me try to make that bigger. So that is a value. Now, if I want to find out the type of that value, I'll go in and use the type function. Remember, functions always have parentheses around them. Within those parentheses, I give it a parameter. So in there, I can type in 120. And if I execute it, I can execute, or I can press Shift Enter on my keyboard. It tells me this is an int. If I went ahead and typed in mango, Python tells me that's an error. Why is that? Because mango is not defined. It thinks it's something else. The way you write strings, you have to put them in quotes. So when you put strings in quotes, then your computer, your interpreter, Python understands that that is a string. You yourself, when you see it, you understand that is a string. So let me make this smaller a little bit. So this error is telling me there's an input error in item number 3. It does not know mango at all. So this is an example of us making a mistake in our language. This is an example of us talking gibberish, right? Which is totally okay. It's totally fine. If it was a whole long script, it would be able to tell us where exactly on that script that the error is. In order for us to fix it, all we have to do is make sure that we type in mango in quotes. If I do that, then it knows that, okay, you're telling me that is a string. Does that make sense? Awesome. So again, these again are just literal values that you're writing in your Python console. Okay, the values don't really mean much now. We just know that each value has a particular type. All right, so let me switch back over, and then we can go from there. Let's see something more interesting. I mean, if we're going to be writing code, there's a way that we probably want to be able to keep track of our values. Okay, if we want to keep track of our values, we need to take them and store them somewhere. Okay, so a value has to be given a name. We usually give names to values. Those are referred to as variables. Okay, so think about, I cannot be holding my mango in my hand and grabbing mangoes from left and right. It's better for me to put it in a bucket. And then I know that that bucket is DK's mangoes. If you want to pick up your own mangoes, pick your mangoes and put in your bucket. You put a tab or a tag on it, container, that's yours. So yesterday we talked about how we write programs and save them in memory. The reason we have these variables is because we are giving ourselves a location in memory to say, okay, save me this value in here. Tomorrow I'll come and look for it. Or another day I might come back and look for it. Just like, you can be receiving your paycheck and eating all your money, or you can decide to open a bank account. When you go and open a bank account, you have to say what type of account it is. So think about this like going to create a bank account. Some people would want to be putting their gold in there. Some people might be putting their jewelry. Some people might be putting their books or important documents. That is why we need to define the data type. If the computer knows that you're going to be storing integer, it knows I'm going to keep you this space. If it knows that you're going to be storing a string, then it looks for a bigger space in memory that's going to be reserved for that. So each of these data types have different ranges in their sizes. That's why the computer can know that. But importantly, you want to give it a name, okay? So you write an assignment statement, which we'll talk about later on, to be able to create a new variable and give it a name, and then assign that value in there. So I'm going to get a bucket, give that bucket a name, take my stuff and put it in there. Or I'm going to get a safety deposit box, give it a particular number, you have the key to that box, that's where all your stuff is, okay? Because throughout the lifetime of your program, you're going to go back in there and grab that number and use it. But remember that just because you open your bank account with $100, it doesn't mean your bank account is only going to have $100. Tomorrow, you might decide to remove that $100. The next day, you might decide to add $3,000 and so on and so forth. So it's just a bucket. The values that's going to be assigned in there is going to change along the way as your program continues to execute. Make sense? So that's how you would define a variable, okay? Just a placeholder. But as much as we know that, we have the liberty of giving our variable any name, Python has a few recommendations. Variable names cannot be any of these words, these keywords, because these words, Python uses it for its own native programming. Words like false, none, true, del, def, continue, class, and so on. If you try to give those names to your variables, the Python interpreter is going to yell back at you and say no can do, okay? So what you need to do is you need to give it any other name. Most people write programs and say A equal to this, B equal to that, C equal to that. That's not a very good idea. The names that you give for your programs need to be mnemonic. It needs to mean something to you. Because guess what? You're going to come back tomorrow to look at that code. You're not going to remember what the heck you were doing. Somebody else on your team might be looking at that code and be like, what did he mean by XYZ equal to this? So it's better to give it a name that has a good meaning. And that's going to be, nobody in the programming world wants to be looking at somebody's code with some names that don't mean really much stuff. So give some good names to your variables and it's going to save you a lot of headache, okay? Another thing is there are some illegal names that you cannot give. Just like I said, these keywords. We talked about languages. When you grow up, they tell you there are some bad words that you cannot say. If you say those bad words, you get a whooping. So think about it. It's the same thing in Python. No, cannot use these bad words because you get a whooping. Also, you cannot start giving the name of a variable with a number. It must start with a letter, or you can start with an underscore. Most of the time, they don't want to use underscore except you're using it for a library that you want to export. So you want people to use that specific name. But remember, again, there are some illegal names that you don't want to use. There are some names that are totally meaningless, except you make it mnemonic. Finally, in Python, there is encouragement of using a snake case. Is anybody familiar with either snake case, camel case, or Pascal case? Not at all. Everybody is on mute. Go ahead, Aaron.
No, just hearing that for my first time.
Okay, so normally, let me go ahead and get out of here again. Normally, when you write words, right, you can write it in uppercase or lowercase. So let me go ahead and add a new cell. This would be uppercase, and this would be lowercase. But in programming, in most programming languages, rather than having the boy as the word, they'll usually take away the space in between the E and the B to join it together to be one word. Okay, so if you write it that way, that is, let's say, proper case. But if you want to write camel case usually starts with a lowercase, and right after the space, you capitalize the next word. So that would be camel case. That's why you see I write it this way, camel case, because this C right here makes it look like the hump of a camel. Okay, but in some cases, you might need to start with a capital letter. If you start with a capital letter, then it is Pascal case, because Pascal is the name of a person. Pascal is, I think, is a French mathematician that I'm not sure what exactly he did. So that's the difference between proper case, camel case, and Pascal case. Now, snake case is when you use an underscore. And Python uses snake case because it's more readable. It's easy for you to read that rather than the camel case, because you have to squint to see if it's uppercase or lowercase. Does that make sense? So the names that you give your variables, you're very much encouraged to use snake case, but nobody forces you. But it's just programs that you see out there. Most of them will have snake case for Python. For other programming languages, it might be different, but this is what's encouraged for Python. Sounds good? Okay. Yeah. Question, Mr. Nigel.
Yes, Prof. So, for example, I know. So you have written snake. Let's get it correctly. You have written snake case in snake case, right? So
yes,
if you were to write the boy, you will have all lower letters with an undercase in between the E and the C.
Yes.
And the okay. All right.
That would be the boy in snake case.
All right. Gotcha. Thank you.
You are welcome. Question, Aaron.
Yeah, not that I know what I'm doing actually, but it looks like so. So so technically you cannot use proper case, right?
Technically, you can use anything, but if you share your code with someone that is wanting to use Pythonic code, remember Pythonic code when we talked about? Let me open a new cell. When we talked about import this was giving you all the ideas of how you want your code to look like. Okay, so when you write the boy in snake case, it's actually talking about sparse is better than dense. Because of that space in there, you can clearly read, you can clearly see what is actually going on, and it's easily readable. But that's fine. If you want to make it dense, that's totally fine. It's just going to be not as readable as the sparse one. Does that help?
Yeah, because actually I've been using Pascal and Snake, just mixing them up without even knowing what I was doing, right?
Yeah. Yeah, if somebody looks at your code, then they'll be like, yeah, your code is not very Pythonic. And you'll be like, what are you talking about? But it's not a big deal. Your code is going to run totally fine, no problem. But if you want to have your code to look clean and neat, then you want to, everybody is encouraged to use snake case.
Okay, that's good to know. Thank you.
You're welcome. You're welcome. And a question from Fabian: are the words case sensitive? They are case sensitive. So I think to really answer your question, we'll probably have to go to the next slide and then test it out so that you can see clearly what exactly is going on. But Python is definitely case sensitive. If you give,
this was long before I was asking about the keywords, the ones that you said are reserved words.
Oh yes, the keywords.
Because I saw like from with uppercase F, but I don't know whether if we were to use from with lowercase, it would still constitute a reserved word.
Good. So the best thing we can do right now is let's figure out and answer your question. So let's try to create a variable, right? An example of a variable we had, what number did we use before? We said 120. So let me go ahead and say the, I don't know, number of mangoes. Number of mangoes is equal to 120. That's how I'll go ahead to create a variable called number of mangoes and assign the value. This is an assignment operator, and I assign the value of 120. And if I press enter, nothing really gets done because I'm not printing anything to the output. If I use that print function that we've been using all along, and now I type in number of mangoes. What I did here is I started typing NUM, and then I use the tab to complete it for me. Okay, because that's the only one I have. So if I press tab, it completes it for me. It helps me avoid having typos because I might make a mistake. So if I print that and I do play, it prints the value that is inside that bucket, that is in that memory location, because there's a memory location in there. I could go ahead and just say A equal to 120. And then I can go ahead and print that A. It's still going to give me the same answer. But when you come back tomorrow, you're going to ask yourself, what was A? Was it bananas or oranges? That's why it's better to give your variable a mnemonic name, a name that actually means something, rather than having that. Obviously, you're not going to go ahead and say 6 mangoes equal to 6. That's going to give you an error if we try executing it. And that's because it's an invalid syntax. You cannot start the name of a variable with a number. So that's illegal. Okay. So if we try using the from to be a variable, you can see that it's already highlighted because this is an IDE. So if I say from equal to 7 and I execute that, it's also going to give me an error because from is a reserved word. If I use a capital letter equal to 7, then it's not an error. So it's not it is case sensitive rather. Does that make sense?
Perfect. Thanks.
So now I can go ahead and print from. It should be just fine. But obviously you want to avoid using any of those keywords because it's going to be problematic for someone to try to read your code. Sounds good? So definitely you don't want to give your variable a name like this because this is going to be causing you a lot of you're going to become very unpopular on your team when people start seeing you writing code like that. So it's better to go ahead and just say mangoes or maybe singular and you're fine. When you execute that, this has been saved in Mango. No matter when you come back and you execute it, it's going to be able to know that that's the value that you saved in that memory location. And the CPU can take it from there and run with it really, really quickly. Everybody good with this so far?
Yep.
Excellent, excellent. So the reason, again, as you can see, why I'm using Python with Anaconda notebook, or should I say Jupyter notebook, is because we can test these things out easily. We can write every single line of code and execute it easily, rather than using a Python script. Eventually, we're going to start using scripts when we have gotten to the meat of it. But for now, understanding the basic concepts, we need to be able to just break it down in here. Like I said, don't be afraid that you're going to break anything. Just go ahead and test out your scenario and then figure out what the issue is. Sounds good? So a quick example we might want to do, let's say we want to solve a particular issue of calculating tax. And I think I'm probably going to show you that in a little bit. Let me make sure that I cover something else that we might need, which is a statement. And before I cover a statement, let me go back and make sure that we double check again. We've gotten everything on here, all these keywords. False always starts with a capital F, true with a capital T. The rest of them are all lower cases. So definitely case sensitive, or actually none. I've totally forgot about that. None is also capital N. So we've talked about values, we've talked about data types, we've talked about variables. Let's proceed now and talk about statements, okay? A statement is an instruction, just a line of code, right? That's pretty much a unit of code, but the statements could be executed or not executed. The statements that are executed are usually not commented out. So sometimes you want to skip a line of code if you have already gotten what you need, or for debugging purposes. You might also want to write information in your code that's going to be helpful for you in future or for some other person looking at your code. In that case, you add a pound or a hash or a hashtag in front of the code, and it's going to be skipped when the interpreter goes over it, okay? So that's what a comment is. Every programming language has a comment. That's usually, in the past, it was mostly used for, adding information about the code, but now in production code that lives in a production environment or in a live environment, it's really frowned upon, but it's good to have it in your development environment to help you out to say, if for instance, you want to solve a problem you might outline the steps to solve the problem and then go after each comment and write the actual code that needs to be done. That's known as pseudocode. Writing code in your own words and then going in to use the programming language to actually write the particular thing that you're trying to solve, the problem you're trying to solve. So again, a statement, as you have seen, multiple statements that we've talked about today. Your statements, if you write them in the interactive mode, just like we've been doing in each of those cells, just like you can do on the console in Python using the Python, should I say the Python IDLE, the Integrated Development and Learning Environment. What happens is the interpreter reads it, it executes it, it displays the result if there is one, and then just loops back. That's what REPL stands for. Read, evaluate, print, and loop. Okay, so that's how you execute each line of code. But if you decide to write multiple statements or even one statement in a file and save it, that's still a Python script. So if you write print hello world or print your name, that is a Python script that has one instruction that's saved in a file. Make sure that your file ends with .py for Python. If that's the case, whatever happens when you execute that file, which contains a sequence of statements, the results are also going to appear on the console, one at a time, one after another. If you write a piece of code, let's go back in here. Oops, not there. All right. Let me switch back to the other screen. If you write a piece of code that says, in this case, we have mango, from, and so on. If I go ahead and do print from, and then I do print mango, oops. And then I do print, say hello. Oops, that was a typo right there. This will be more or less like a script. If I execute this, it's going to go ahead and print all three of them. It remembers that from had 7 assigned to it. It remembers that mango had 21 assigned to it. And it also goes ahead and prints this. Does that make sense to everyone? And just like we said earlier, if we want to check what data type is in the mango, maybe we did not know, all we have to do is do type, and then we enter mango in there, because mango is a variable. Mango is holding the value that we have assigned in that space, in that container, in that memory location. If we execute this, it tells you mango is an integer. Question, Fabian?
Yes, I have 2 questions here.
Yes.
One, you said REPL is read, evaluate, or what were the other 2 ones?
So it's read,
yes,
evaluate, print, and then loop. So
okay.
after it prints, it looks back and then it asks for more, because that guy is just hungry. That CPU, it's so fast. All it wants is that you should give it something to do. So it's whatever you give it, it's going to read it, evaluate it, give you the result, and then ask you for more input.
Okay, given the example that you just did,
yes,
if you scroll, okay, we know that we had defined a variable or assigned a value to the variable form, then
yes,
mango in that order,
yes,
right? But if we were to reverse and put print mango first, then from down, would it, that sequence, what is the sequence there? How does it read, like from top to bottom based on how you define it? I know with other programming tools, for example, say like Terraform, when you're defining AWS resources, Terraform is actually intelligent to know that, okay, I need to create this before this. You don't necessarily need to place them in a specific order, right? But in this case of Python, is it the same concept?
yes. Again, what you did here is, this guy comes into the bank and he says, I want you to take 7 and save it in this space. Another guy comes into the bank called Mango. I want you to save 21 in Mango. They are all located in memory. Memory can pick it up in any order. But when you come now and ask a question with the print function, you're saying, hey, print mango first. Sorry, print from first, then print mango, and then print hello. Then it's going to do it in that order. That's why in here, I did mention that. Oops, wrong one. The results would appear one at a time as the statements execute.
Okay.
Okay, so the first statement to execute, oops, I keep doing that. The first statement to execute is the print from. The next statement to execute is the print mango. And the last statement to execute is the one with the hello.
Thank you.
You are very welcome. All right, very good questions. Any other questions, anybody? Yes, Mr. Anji.
So, Prof, because I'm just a follow-up on that question that you just responded. Consider we write a print statement saying, okay, print mango first, and then print from second, and then finally print hello everyone. Is that still gonna come as you give the statements, or does it have to follow just that format and say, okay, mango first came in first, let me give him the result. Then sorry, from came first, let me give him the result. Mango came second. I don't know if that is clear.
Very good question. So again, let's try it out. If I go ahead and say print 1 + 1, and then I go ahead and say print mango, and maybe go ahead and say print how are you? It is going to first print 2, and then print whatever value was stored in mango, and then print how are you? And let's go ahead and even print from as well. And you'll go ahead and print that as well. So let's execute that. And you see it prints it in that order. Does that make sense?
Yeah, clears my doubt. Thank you.
Excellent. So pretty much again, it's the order in which those instructions are given. So that's why it's very important to list your instructions in order. Just like we said yesterday, if you have given instructions to your child that every time I tell you get ready for school, you have to first go and make breakfast before you brush your teeth, before you make up your bed, and so on. That's the order that it's going to follow. So if the order does not work, you have to go back. That's why in software development, there's the planning phase. You go ahead and plan and get all the information that you need. They'll do the designing. They'll say, okay, the system has to do this and that before it does this and that. And then you go into development. After this is been designed, you develop it. And then those other guys that are quality assurance guys, they do quality analysis or quality engineers to come in and test it to make sure that what you want is what you're actually expecting back. Okay. So again, you want to make sure that there are two types of errors actually. There's a semantic error and there's a syntactic error. So semantic meaning it sounds correct, but it's giving you the wrong thing. While syntactic, it means you're not writing it correctly. So for instance, I know that I want to say the cost of something is equal to 1,000. Okay, that's good. I can now go ahead and say print the cost. If I do this, I don't get any errors. But if I went ahead and said the new cost, new cost is equal to 1,000. That is a syntax. That is a syntax error. Okay, because now, sorry, I actually made a mistake. I needed to print it. So let's print new cost in this case. If I print new cost, that is not what I was expecting. Okay, because I entered it with a comma. Python is thinking that I'm entering two separate numbers instead of entering one number. So even though we know 1,000 has 3 zeros, you don't need to add a comma in there. So here it did not tell us this is an error. If I had another, let's say another cost, say it's equal to 1,000, and then I print another cost. This works just fine. So this is a good answer, and that is a wrong answer for this one, because if I went ahead and got this and I don't print it to see what my value is, tomorrow when I want to use that value, I'll get an error message, not knowing that that's because I had a comma in there. Okay. Again, if I had another value and say, let me put A in there, and try to print it, it gives me an error. This is a syntax error. This is a semantic error because it doesn't do what we are expecting it to do. Does that make sense to everyone?
Yes, so line 20, to solve that, would you wrap it in double quote or?
Very good point. So to solve line 20, the question that Fabian is asking, should we wrap this in double quotes? That would definitely change the issue. It's not going to solve it though. So rather than me doing that, let me undo that and then let's try it in another cell. Let's say newer cost is now equals to, even if we do 1,000 and go ahead and print newer cost. What do you guys think we'll get? Anybody?
It's going to be a string, right? It looks like it's going to be a string.
There you go. Very good, Aaron. So it prints that out, but what we need to do is check the type. If we type it out that way, we can see that newer cost, is going to tell us that is a different data type, str for string. Does that answer your question, Fabian?
Interesting, yeah.
Yes, so you have to be very careful. Like I said, the CPU is very dumb, but very fast. So whatever you give it, it's not going to figure you out and say, you know, this is what you're trying to do. That's why if we go back to our Zen of Python, it's better to be explicit than to be implicit. You know, as much as we're implying that we want it to be 1,000, we should definitely be explicit. And your friend is always going to be this type function to check out what exactly your data type is. So those are ways that you can debug. And that's something we talked about yesterday, that Python was dynamically semantic or something like that. You know, it was not static. It did not have static semantics. In other programming languages like Java, C, and so on, before you want to use newer cost, you have to define it. You have to say, hey, I want this variable to be of this data type. But in Python, you don't define any variable. You just go ahead and create it, and then you're good to go. So for some people, it's a good idea. Others, it's not a good idea. Most people that do testing, quality engineers and quality analysts, they will not like it because they'll have to go in and test. You know, this is probably one of the things they'll do to test and make sure that your data type works just fine. Sounds good? What questions do we have?
No, but you had an alternative to fixing that line 20.
Yes, an alternative to fixing line 20 would be just to take away that. Why is it not? Take away that comma, and then it's pretty much just like line 18 now.
Oh, okay.
So if I execute this, now it's 1,000. Okay?
Okay.
Another thing we might do, which is data types, as you see, newer cost is now a string. We can go ahead and convert it. For instance, we can say newer cost with a comma or without a comma. This is still going to be a string. Okay? But if you want to convert one data type to another, I don't actually have it in my slide because I was hoping to tell you guys later. I can go ahead and change my newer cost to be an integer by casting it. So I would say int and do that. So it's saying take this number, whatever it is, change it to an integer. So I can go ahead and say this is integer cost. And this value now gets assigned to integer cost. And I can go ahead and print that. I can also go ahead and check the type. So again, 3 things are going to happen here. The first line is going to go ahead, take newer cost, convert it to integer, and assign it to integer cost. The next line is going to print that value within that container, within that bucket. The third one is going to give us what type is in there. So let's go ahead and execute that. You can see 1,000 is now an integer.
Oh God, you're making this whole thing really fun.
That's good. That's good. That's good. That's the point, you know, that's the point of us, you know, doing it this way. So going back to our PowerPoint, we have seen a few things here. We've seen that a statement, you can write it interactively on the console and it will read, evaluate, print, and loop back and ask you for more stuff because it's that hungry. You can write it in a file, save it, and then execute that file. The results are going to appear one at a time. But there are two types of statements, as we have just seen. There are statements that are used for assignment. So you're taking things and assigning them to variables. In that case, you have no output, right? And that's something we just saw right here. I wrote 3 statements. This first statement did not have an output because I just assigned it. Only these 2 statements had outputs. The first one that printed and the next one that gave us the report that it's an integer. So 2 types of statements. Assignment statements has no output. Expression statements has an output. But the expressions is the next thing that we're going to talk about.